Welcome back. The objective of this video is to do a couple more samples and analyze a little bit more end behavior of rational functions. The end behavior of a rational function will be affected most by the polynomial with the greater degree, as its values will dominate the values of the rational function for input values of large magnitude. So that's when we were evaluating for really big x's, both positive and negative. For input values of large magnitude, a polynomial is dominated by its leading term, which should be the one with the highest degree. Therefore, the end behavior of a rational function can be understood by examining the corresponding quotient of the leading terms, so that battle between the numerator and the denominator. Example 3 says, describe the end behavior for the graph of the rational functions. Analyze using limit notation to explain your answer. So for A, our leading coefficients and our highest degree in the numerator is 2x to the fifth and the denominator is x cubed. So we're going to analyze those two highest degrees. It's the battle between these two guys, and those two will simplify to 2x squared. So using limit notation, the limit of 2x squared as x approaches negative infinity, well, that is going to go to positive infinity. And the limit of 2x squared as x approaches positive infinity, so as we choose really big positive x's, that also will go to positive infinity. Sample B. Well, they got a little sneaky here, and they haven't written this in decreasing order of x, but we're going to look at the battle between negative 5x to the fourth in the numerator and x in the denominator. So here we'll consider only negative 5x to the fourth over x, which is going to simplify to negative 5x cubed. So we want to see the limit of negative 5x cubed as x approaches negative infinity. So our x cubed is going to be negative, and then we have a negative 5 times a negative. That is actually going to go to positive infinity. And the limit of negative 5x cubed as x approaches positive infinity, well, that is going to go to negative infinity. And that wraps up this video on end behavior, and we'll get some more practice with this when I see you in class.